Hey guys, I'm continuing on with the Philco 60 restoration project. I went through 4 rounds of putting on primer and sanding, and now it's really nice and smooth. All of the pits from the heavily rusted areas are filled in now. So I moved on to this aluminum enamel paint, and I'm pleasantly surprised at how good it looks. In the past I've been not too happy with metallic paints. They just don't look. They just didn't look so good. But this looks really good, and looks a lot like the original coating. So, for example, here is the aluminum enamel, and here is the original CAD plating, and I think that's a really good match. Now, this is just the first coat. I'm going over this reddish primer, so I imagine I'll have to put on at least one more coat to fully cover it. And it takes 24 hours for each coat to dry, so it's going to be a couple days to finish this process. In the meantime, I'm going to restuff those electrolytics. While I wait for the paint on the chassis to dry, I'm going to rebuild the 2 electrolytic capacitors. These are what they call wet type electrolytics, meaning there was literally a liquid in here, which has long since evaporated out, I imagine, through this old cracked rubber gasket on the bottom here. In fact, if you recall my earlier videos, these had already been replaced with these capacitors, which are also so old I'm sure they're no good anymore. Stamped on here there were originally 8 microfarad, 475 volts. These replacements were 8 microfarad, 450 working volts DC, and 525 VSP, which is probably like volts surge or something along those lines. Well, commonly the capacitors I get from Mauser. I use Nichicons, and the largest voltage they have is 450. And since these are rated for 475, and I know from experience that tube radios, when you turn them on, can surge up pretty high in voltage, so I picked up some 500 volt caps from Just Radio. Maybe even 550 or 600 would be great, but I'll see once I get this radio back together and running. I'll see what kind of voltage surge I'm really getting, but for the time being I'll go with these. They are 10 microfarad, which is a little bit larger, but should be okay. I wouldn't go much larger than this though. Otherwise, when you turn the radio on, there's a current surge to charge these capacitors up, which could damage a transformer or the 80 rectifier tube. But these are not a whole lot higher, so I think I'll be okay. So what I did is I cut open the end on this one. The way these were wired in is the positive terminal comes out this hole in the end here, and the can is negative. Same on this. But the way this radio is set up, the negative leads on the capacitor do not go to ground. They go to the end of this resistor network, which goes to ground. That's so they can develop some negative potential here and here to bias the tubes. So you do not mount these and have this metal touch the chassis. That would really mess up your radio. You don't want to do that. You need to use this insulator, which in this case these are in pretty good shape, so I'm going to try to reuse these. And for the negative terminal, it's this guy here, which is actually just a piece of metal that was just held on by pressure. Because this can is aluminum, this is steel, they really don't solder very well together, so it was just the pressure of this cardboard sleeve against that terminal that made this connection here. So when I rebuild these, what I plan on doing is running the positive lead right out through this center. I'll clean out this old rubber and run the positive terminal out here with some type of insulation around it, like heat shrink tubing. And for the negative, I think what I'll do is maybe drill a small hole in the side of the can here and run the negative lead out and solder it onto this terminal. Either that, or I'll drill a small hole in the bottom of the can and wrap it around the bottom down here. At any rate, I do plan to solder it to this terminal in some manner. As for what's inside, oh, I should say, I put a reference mark on here and I cut it open with a hacksaw. So when I put it back together, I can get this lined up pretty well. The line isn't really necessary. I mean, it's circular, but because I cut it by hand, it's a little bit jagged. So if I do this, I know that it lines up pretty well. And it really doesn't matter how jagged I cut it because, of course, it'll be covered in this cardboard sleeve. I also plan on making this so it can be reopened. I'm not going to use something like really strong epoxy or JB Weld to seal this back up. I'll use, or I'll try to make like an inner collar so it's kind of a friction fit. Plus this will help hold it together too. Just in case there's ever any problem in the future, this could be popped back open and the capacitor replaced. So as for what's inside, well, there is the I guess that's all that's left of the electrolyte, so whatever this crystal is, hopefully it's not too horribly toxic or anything, but I imagine if I added water to this, I'd probably be able to reconstitute the electrolyte. And there's a insulating mesh, I think, comes out pretty easily. So the can formed one electrode, and then there was an insulator. And then there's this spiral of metal mesh, and this would have floated in an electrolyte solution. This is kind of like a battery, I suppose, like a lead-acid battery, and this is what formed the capacitor. So I can cut all this away, and then try to clean up that bottom down there. I just cut into the second cap, and I started hissing and oozing, so I think this one's going to be a little bit more interesting, because there's some liquid left in there. Better get out some paper towels so I don't get my workbench all messy. Yeah, this cap is definitely still damp inside. No liquid electrolyte really pouring out of it, but it's definitely very damp, which unfortunately has kept the insulating mesh really stuck solidly to the sides of the can, unlike the other one where it just slid out. So what I'm going to do is let this dry out overnight, and maybe it will come out more easily then. Otherwise it's the same construction inside. I'm just about done with one of the capacitors. Here it is. What I did was I dug up some strapping of sorts. I think this was meant to go onto a chassis. We screwed on one end, feed wires through, and then twist this around it. But at any rate, it's basically just a scrap of metal with a hole at either end. I put some heat shrink tubing around that and then fed it through the old rubber, which is still in decent shape, but not quite so much that I would trust it for insulation, so I wrapped some heat shrink tubing around this and then shrunk it before I slid it through, actually, so there's more insulation than just that old rubber. There's actually a sleeve of heat shrink tubing around that. Then onto the end that protrudes, I salvaged the old solder terminal from the capacitor, and then I crimped that on the end, which it gave me that, which is pretty much identical to the original. Then on the other end, I put some more heat shrink tubing on, and inside that big loop there I attached a bit of wire because the capacitor lead just wasn't quite long enough to come around, and I soldered that on. Now that's the positive terminal. Important to keep that in mind. Positive goes up to the center terminal there. Now for the negative terminal, that's the trickier one because you can't really solder onto aluminum. So what I did is I drilled a very small hole there, and I fed the negative lead of the capacitor through it. And then I took that clip that just rubs up against the lip of the can there by pressure, and then that gets covered up by this cardboard sleeve. And I wrapped that lead around it and soldered it on, so you know it's really not noticeable. And then simply slide the can back over, and there it is. And then of course the last bit is the cardboard goes over it, which completely covers up all that work I did, so nobody would ever be the wiser. One thing I do want to do though is I could just trust this cardboard and the clamp that holds the capacitor in place to hold this all together, but I don't think that'll be quite sturdy enough, so I'm gonna dig up something so that I can glue like an inner lip around this, like a collar, so that when it slides on here there's a little bit of something gripping it. Maybe I'll find some kind of sheet metal or something that I can glue into there. And I guess finally I'll polish up this aluminum a little bit. Originally this had Philco and a part number, and it was kind of a decal or stenciled on there, but it's already so worn off that I think I'll just polish up this whole can and not worry about reproducing it. It's in a little bit better shape on the other can, but the aluminum's pretty tarnished, so I think I'll just polish this one up as well. Here's the two rebuilt capacitors. Before sliding on the cardboard sleeve, I polished up the aluminum with some Simichrome. And while doing so, I noticed something kind of interesting. The markings on these cans aren't quite the same. This says 61115, and this is one that was all dried out and just had powder inside. And this has 61116, and this is one that still had some liquid inside. Also, the tops are a bit different. The one that ends with 5 is flat, and the one that ends with 6 is a bit of a dome on top. So perhaps the one that still had liquid in it was an old replacement. Guess I'll never know, but I thought that was kind of interesting. Now, I did not glue these back together or seal them in any way. It's just the cardboard holding them together. I'm going to leave it like that until the radio is completely done and functioning, just in case I have to get back inside here and replace the caps or do any repairs or anything like that. I have a little bit left to do on the chassis, and then I can start putting this radio back together again. I'm just about done rebuilding another part of the radio. This is the tone control. 2-position switch. The way this works is there are 2 capacitors that are tied together at a common end, which goes over to the audio output tube. These are the 2 capacitors right here, and there's that common lead that goes to the plate of the capacitor. And one of them is always going to ground, and the other one is switchable. So when the switch is closed, it puts these capacitors in parallel, which increases the capacitance. And when it's open, it decreases the capacitance. And that will have the effect of forming a filter to knock out some of the frequencies. So the body of this is ground, and one of the capacitors is just soldered right here to the frame, and the other one goes to this, which is an insulated contact. You can see it's got some black insulation there. And then there's this movable contact, which is actually silver-plated brass, I believe. And so in that position, the switch is, or the capacitor is out of the circuit, and when it's thrown the other way, it's now in the circuit. What I'm going to do now is take some black hot glue and fill this tub in. Originally there was tar, but I want to use hot glue. I don't want to leave it like this because it's just too loose and flopping around. And then here's a piece of modern cloth covered wire that'll run over to the output tube in the radio. Here it is after the hot glue is set up. Pretty good simulation of the original tar, and it certainly holds everything firmly in place.